Hi, welcome back. In this video, we're going to talk about 7.1 ratios and proportions. This might feel like a review of middle school, and in one way it will be, because this is going to be laying a foundation for the rest of our chapter on proportions or on similarities. If you are new to the channel, or if you have not subscribed yet, go ahead and do so now. I will post a video in here over every topic we discuss in class all year. Okay, so it'll help if you're absent or if you need more guidance with the homework or the stuff that we're doing in class. I will also from time to time post videos on non-math related videos that hopefully are also helpful. All right, let's go ahead and begin. Let's first start by defining a ratio. A ratio is used as a way to compare two or more quantities. If you're comparing two or more objects or two or more quantities or things, you can express it in several ways. You can write it using words, fraction, or a colon. So for example, let's say that you're comparing the ratio of boys to girls. You can say the ratio of boys, the ratio of boys to girls is maybe it's 6 to 5. For every 6 boys, there's 5 girls. You can write it as a fraction, 6 to 5, or as a colon, 6 to 5. The ratio here tells me, right, the numbers, the numerator will be the first one, the denominator will be the second one, or boys to girls. So the order in which we write a ratio is very important. It'll tell us how we're comparing these two quantities. And then using these quantities, we can scale them at larger events, right? We can say the ratio of boys to girls in the campus, in the entire school, or the ratio of boys to girls in the entire world, right? We're comparing these two quantities to be able to make sense of the numbers. Here we have an example that talks about 1 ounce of cheddar cheese containing 9 grams of fat. 6 of those grams of fat are saturated fats. We want to find the ratio. I'll see if I can highlight this. We want to find the ratio of saturated fats to total fats in the ounce of cheese. So what we want to do is we want to write this as a fraction or in words or in however form you want. But I'm going to label this saturated can't spell right now for some reason. Saturated to total fat. So then I look for my numbers. We have 9 grams of fat, and 6 of those grams of fat are saturated fats. So we're going to write 6 is to 9 or we can say 6 over 9. If possible, we can also simplify the ratio. This will be simplified down to, we can also equivalently say, divide the top by 3, you get 2, the bottom by 3, you get 3. So the ratio is 6 to 9 or 2 to 3. And that's more called like a unit ratio. The smallest form you can simplify a ratio to will be that unit ratio, like the scale that we're going to be using. So as long as you're using the right order, saturated to total, find your numbers, write them in that order, and we're set. Now let's talk about a proportion. A proportion is also dealing with ratios. This is when you're comparing two ratios to each other, when you're setting them equal to each other in value. So let's say that we're comparing the ratio of boys to girls in a room. And at the same time, we know that the same ratio, that ratio of boys to girls, is equivalent to the ratio of iPhones to Androids. When those two ratios are equal, we have ourselves a proportion. So let's say that we have a ratio of boys to girls. Maybe we have, for every 4 boys, there's 5 girls, or for every 6 boys, there's 10 girls, or something like that. If that ratio is equal to how many iPhones we have, iPhones to Androids. Right? Whenever two different ratios are equal in value, we say that they are proportional. They make a proportion. And here we're going to do an example of how to set up a proportion and how we use those equivalent ratios to scale them up and to grow. For example, if I know the ratio of boys to girls is 4 to 5. For every 4 boys, we have 5 girls. Then that means that for every 4 iPhones, we will have 5 Androids, right? They will scale at the same rate. That's what makes them proportional. So here we have an example of the ratio of goats to sheep. We're dealing with some animals. Goats to sheep. They sound very similar, but they're quite different. Some of them are more aggressive than others. So the ratio is 4 to 7. Okay, so we have goats to sheep. I'm going to write it as G. Sorry. The ratio of goats to sheep is 4 over 7. That's the ratio we're dealing with. Now, we also know that the number of sheep in a farm is 28. So I know this value down here. I'll rewrite the fraction. I can also write this as goats over 28, because that's how many sheep we have, will equal 4 over 7. And we can use the fact that we know the ratio of 4 over 7 to calculate the missing number of goats. And what we would do here is we would cross multiply and solve for a missing value. So when you solve proportions, you're going to want to cross multiply. Okay, and here I'll show you the color. So you multiply to the right and you multiply to the left. So first you have 7 times g, giving you 7g, equals 28 times 4. 28 times 4 is going to be 112. Okay? Notice how the fractions disappear, and we're just left with 7g equals 112. If we wanted to solve for g, now we would have to leave g by itself, so we divide both sides by 7. We divide the left by 7, we divide the right by 7, and we're left with g equals 16. For every 4 goats, we have 7 sheep. So if we have 28 sheep, how many goats will we have? How can we predict that? We set up a proportion, and as long as you write the proportion in that order, goats to sheep, we can just cross multiply and solve for whatever you're missing. So here are some more examples of how to solve proportions, just in case you would like some more practice. If you feel like you know how to solve a proportion, or you know what a ratio does and how it works, you can go ahead and just like this button and sign off. Or you can continue looking at some more examples on how to solve in case you would like some more practice with it. I recommend here at this point to pause the video and give it a try yourself. Solve the problem, solve for x, and then press play and see if I get the same solution as you. So I'm going to multiply 12 times 5, because I'm cross multiplying in my proportion. 5 times 12 is 60. And then on the right side, I have 8 times x. Once you multiply both sides, you divide by 8 to leave x by itself. I'm sorry about that. The 8's cancel, and that leaves us with x equals 60 divided by 8, which is 7.5. On the other one, very similar, except that a little bit different, because if you notice, we have 2 terms in the top. So whenever I have multiple terms, I'm going to put it in parentheses. Because when I cross multiply, I have to multiply 7 times everything inside the parentheses. And on the right side, I have 4 times negative 5, which is negative 20. On the left, because I'm multiplying by 2 terms, I have to do distributive property. 7 times 3x and 7 times negative 5. So that gives me 21x minus 35 equals negative 20. To isolate the variable and leave x by itself, I add 35 to both sides. Leaving us with 21x equals 35 minus 20 is 15. And we divide both sides by 21. So x equals 15 over 21. Or if we simplify it, notice that the numerator is divisible by 3, which gives us 5. And the denominator is also divisible by 3. 21 divided by 3 is 7. So 5 over 7. Sorry, my handwriting is a little bit off right now. And there it is. To solve a proportion, you cross multiply. And if you happen to have two terms, make sure you distribute into both terms. And then the rest is an algebra problem, right? Distributive property or solving for x, leave x by itself. And that's pretty much it. I hope this has helped. If you have any further questions, you can feel comment below at any particular point that you got stuck or are not so sure what it means. Please let me know if you have any questions. And as always, we'll calc you later.